Another significant abstract data type is the priority queue. So a priority queue is actually very much like a regular queue. In fact, we'll give it the same methods, the exact same methods that our regular queue had. But the contract, as far as what they do, is slightly different. So let's go ahead and we will create we'll go ahead and we'll make a new package called priority queue. And I'm going to put inside of here a new trait just called priority queue. Priority queue will work with type A, and I'm literally going to go and lift the code from our previous regular queue and stick it into here. So what's going to change? Well, adding an item to the queue for in queue, no change. Peeking, giving back the next item that would be dequeued, I don't have to change that because I wrote it in terms of dequeue. And then is empty stays the same. The one difference is the dequeue. The regular queue removed the item that had been there longest. It was a FIFO data structure. That is not how a priority queue works. In a priority queue, every element has a priority, and things are removed in order of their priority, so the highest priority thing comes off first. There are many different examples of where kind of priority queues appear in regular life. Queues are one of these idealized things. Everyone is treated exactly the same. But the reality is not everyone is treated exactly the same. And sometimes that's because of a social injustice type of thing. But other times it makes sense. If you go into the ER with a non-life-threatening issue, you're going to sit there for quite a while, mainly because the people with life-threatening issues all go in front of you. But that's not a bad thing. That's how it should work. And they refer to it as triage. Okay, that is basically a priority queue. They pull off the patients from their queue of patients, not in the order they arrived, but in order of their priority. How severe is their condition? So we're going to change this. Removes the item with the highest priority. Sometimes you can make it so that it takes the highest priority that has been there the longest in the case of ties, but we're not going to worry about that for our implementations here. It adds a complexity that it turns out for a lot of priority queues doesn't matter. A lot of times you don't have ties. If you did worry about that, it would change your implementation a little bit. So that's the ADT. Okay. And now we need to ask how we're going to implement it, because an abstract data type can be implemented in many different ways. And it turns out, just like I can implement my regular queue with either an array or a linked list, I can implement a priority queue with either an array or a linked list. Not only that, but I can implement them in two different ways. Okay, I can implement it one way where let's pick either an array or a linked list. If I go with a linked list, where I keep the elements in that linked list sorted, okay, so that the highest priority thing is always at an end ready for me to take off. Or I can store them in a way so they are unsorted, and then when I go to take things off, I go through looking for the highest priority item. We're going to consider those two implementations, we're going to write code for them, and we're going to look at the relative efficiency of the two. Actually, in a later playlist, we're going to come up with a completely different way of implementing a priority queue, just a different approach to storing things and to creating this same abstraction. But for now, we're just going to use simple arrays and lists kind of as the back end.